Understanding how to manipulate dates is a crucial skill in health data analysis. In this lesson, we're going to see how to work with dates in R. We'll see how to parse those dates when you're importing or entering the dates. We'll see how to manipulate them, and we'll see how to format them nicely for our figures and reports. So let's go ahead and get started. Here is our list of learning objectives for the lesson. If you like, you can take a second, pause and read through them, but we're going to come back to them at the end of the lesson. To get started, let's load these packages which we require for the lesson. There's the Pacman package, and we'll use Pacman to load the tidyverse set of packages, and lubridate, which will be our workhorse for this lesson. So I'm going to go ahead and press Command Enter on each of these lines to load all of my packages. Now let's take a look at the data sets we're going to be working with. We'll be working with two data sets. One concerns indoor residual spraying data from a malaria control program in Ilovo in Malawi. Residual here just means that after the place is sprayed, some of the material stays on and continues to kill mosquitoes after the initial spray. That's the residue that continues to stay on. And we can go ahead and import that dataset using this code over here. And we can take a quick look at the IRS dataset here. It has 9 columns and 112 rows. And as you can see, it has a number of date columns, which we're going to use. What this thing shows is basically for each village, the number of targets that were sprayed and what percentage coverage that represents. And finally, the dates for those spraying events. The second dataset we're looking at is simulated data on hospital inpatient stays, which includes admission and discharge dates for 150 patients in different formats. So let's go ahead and read that in and take a quick look at what that is. You can see you have the patient ID and the admission date in a number of different formats, default, abbreviated, and so on. Now that we know about our datasets, let's get introduced to dates in R. In R, there's a specific class for dates, and it's called date with a capital D. Now let's take a look at what that class looks like. The default format for the class is YYYY-MM-DD, where the Y there stands for the year, this stands for the month, and the DD stands for the day, of course. Now, if you just enter a string in that format, R will initially consider it to be a character. Let's look at an example. If we just enter the string, say 2020 0101, which normally would be January 1st of 2020, and we try to run that, we can print that there. Now, if we try to get the class of that object or that value, we'll see that it's just a character. So we need to do something special for R to consider this to be a date. And what we do is we specify using the as.date function. Notice the capital D in this date. So let's go ahead and try that now. We're going to assign this 2020-0101 into my_date using the as.date function. Okay. And when we run that, we can see now that it gives us that the class of this object is a date. And we don't even need the intermediate variable. We could also just do this directly in here. And that would also illustrate the point I'm trying to make, which is that this is now considered to be a date class. Now, what is so special about having this date class? What can we do with date class objects that we couldn't do with the character? Well, here's one very simple thing. We can find the difference between two dates. So with this date class now, let's try and take the difference between two dates. We can take the difference between the 2020 date here, okay, and let's say a 2021 date, okay, or let's go 2019 date. And as we can see, it says this is a time difference of 365 days or 1 year between those two dates. Of course, if we try to do this with just a character, it would not be possible. Let's just go ahead and try that to confirm to ourselves. So I'm going to go 2020-0101 just to match the example up there, minus 2019-0101. And as we can see, it gives us an error. It says non-numeric argument to binary operator. It means we're trying to do something that's numeric to a value that's not actually numeric. And a date class under the hood is actually numeric. This is something that you'll learn as you get more advanced in R. Now, the default format for the as.date function is this string format that I've shown you, which is 4-digit year hyphen 2-digit month hyphen 2-digit day. If you try most other formats, they won't work. For example, here, if we try to parse this as a date, try to get R to recognize this as a date, it says that it is in a standard. It is not in a standard unambiguous format. We can try this one, and that also does not work. There's another format that also works, and that is this one here, where you still have the 4-digit year, 2-digit month, and 2-digit day, but separated by a slash instead of a hyphen, okay? And we can see that R will interpret that correctly and convert it to the default format with the hyphens in between those components. So now that you know about the date format in R, let's look at some ways of coercing or parsing strings into dates from those non-standard formats. We're going to use the IRS dataset for this to look at how R classifies these date variables. Okay, and specifically we'll be examining the columns that contain dates. We'll see how R is going to read those in. So let's take a look now at the IRS dataset, which we already imported. Here I select all variables that contain the string date, and let's run that. We can see that there are 4 of them: start date default, end date default, start date typical, and start date long. Now if you look at the under the names of each of those columns, you can see that only the first 2 are recognized as dates, start date default and end date default. The other 2 were initially read in as characters, okay? And hopefully now you can imagine why that happened, because these 2 are in the first 2 are in the format that R knows how to parse. That is the 4-digit year hyphen 2-digit month hyphen 2-digit day. So now we have to figure out how to tell R that these other 2 columns are also dates. Let's go ahead and see how we do that. Now the first option we're going to consider for parsing or coercing dates is the as.date function that we already saw. As we saw then, this function as.date is used to convert strings into dates in base R. And we're going to try it without specifying the format of our date. So let's take this start date typical column in our data frame. Okay, you can see its format here. And we're going to try to mutate it in order to convert it to a date so it stops being a character. So I'm going to say mutate start date typical equals as.date start date typical. And let's see what happens when we do that. As we can see, this is not what we wanted. It seems to have parsed this as the 7 AD, which is really not what we wanted. Okay, so we need a way to specify the order. And so what is the order that we want to specify? Okay, the original format that this was in is a day slash month 4-digit year. All you have to do is use the format argument in the as.date function. Okay, and there are many symbols that you can use within this format argument. Let's take a quick overview of those. What it works with are basically a bunch of symbols, each preceded by the % here. Okay, that indicate specific formats or specific date components. So take a few seconds to look through this. I'll go through a couple here. You can see that the year component, numeric, is represented with the % and then a capital Y, and that's for the 4-digit year, whereas % lowercase y is for the 2-digit year, and you can see the others there. So let's go ahead and see how we can use this. So now we're going to try to parse the start date typical column using some of those date symbols. And remember that the start date typical column we said looked like this. It is a day and then month and then year. So what we could try to do is find the symbol for day, which is this $D, or sorry, the $D, %M for month, and capital Y for the 4-digit year. So let's try that. So we say start date typical equals as.date, okay, start date typical. So we parse start date typical, and then we give it the format argument, format equals, and we can paste this in here. And let's remove that pipe there, which is a mistake. And if we run that, we can see that it still doesn't work. So why doesn't it work? Well, remember that in this column, what we have in between the day, month, and year are actually these slashes. So you actually need those slashes. Let's go down and see what I just said there. So like I was saying, the format needs to include those slashes in between the each of those components. So now we've copied the old code here, and we're just going to add those slashes. So a slash there and a slash there. And now if we run it, we'll see that we have successfully parsed this date, finally. Now it's going to be time for you to have some practice. So here are 2 practice questions for you. First, I want you to try to coerce the start date long variable from the IRS dataset to the date class, remembering all the elements we have just taught you. So include the symbols that separate the components and use this table that we looked at there to to figure out what the specific symbols are going to be. Then secondly, I want you to look at this one and try to find all the errors in this code. So there are a couple of errors and try to find them all. Now that we've learned about using as.date to parse dates, let's learn about the other option, which is the lubridate package. So lubridate is a package that offers a user-friendly way to convert strings to dates. And the way it works is pretty simple. All you need to do is specify the order of the year, month, and day using just Y, M, and D. And you'll see it's much simpler than the base format way. So you don't have to indicate the separators between the components, and you don't have to use, for example, the B indicator. Remember, we talked about the B indicator here, which stands for month, and that's different. That's for month in words, and that's different from the M, which is for the month in a digit. With lubridate, you don't have to think about that. It's just Y, M, and D for year, month, and day. Okay. So let's look at some examples. We can parse using DMY. We can give any date that starts with the day and then the month and then the year. So let's try, let's say 8th of April 2021. And if I run that, you see it parses successfully into this date. And instead of April, I could write the month 4. So 8/4/2021, and that still works out correctly. We can try maybe, 8 of September, maybe 8 of Sep 2021, and run that. And again, that still works out as you would expect. Now let's try MDY. So with MDY, let's try something like January 1st, 2020. So I'm going to go 01 for the month of January, /01, and then I'll give a space and put 2020, and you see it parses correctly. Okay, I can replace this 01 here with the word Jan, and it still works. I can replace this slash with a space, and it still works. So it's a fairly robust and useful function, as you can see. Let's do the last one with year, month, and day. We can say 2023, let's say May 23. And that still works as it should. And all of these are getting parsed as dates. So if I ask for the class of this here, I will get that it is indeed a date. Now let's apply these lubridate functions to our dataset. So we're going to apply them to the start date long variable. And let's see how that goes. So let's quickly take a look at the start date long variable, start date long. I'll run just this bit here. You can see that it is the month and then the day and then the year. And that's all we need. So we're going to pipe that into mutate and say start date long equals month, day, year of start date long. And that will successfully parse that. And we can run it. And we see that all of those have been successfully parsed. If you want to check that your parsing was correct, you can have this variable be named something different, like let's say start date long conv for converted. And that way you can see both the converted version and the original beside each other to verify that all your date conversions are correct. And now here's another practice question for you. I want you to try to coerce the column start date typical from the IRS dataset to a date class, but now using the functions from the lubridate package. So of course, this will be the MDY, DMY type functions. And here is a second practice question. This will help you compare base and lubridate formatting. I want you to fill in this table showing the symbol syntax you would need to parse each of these dates using both base R and then using lubridate. So I'll quickly do one for you. This one we can see 28/04/2022. That must be a day and then a month and then a year. Okay, so that will be %d, and remember the period here, so period, %m, %m, and then finally a %, capital Y, since this is a 4-digit year. And for this, the lubridate, of course, that would just be DMY. So hopefully that is clear how to do that. Go ahead and try that out. So now we've seen how to convert strings to dates, but how about when you have multiple date formats in a specific column? How are we going to deal with these multiple date formats in a single column? Well, to do this, we're going to introduce the lubridate parseDateTime function. This will help you handle messy dates. And this is very useful because working with dates often involves working with multiple formats within a single column. This is very common when dates are hand entered by the person who is putting in the data. Generally, if your data comes from a software or a source where the dates are cross-checked, then you won't have this problem. But if people have to hand enter data into, for example, an Excel spreadsheet, you may end up with dates in multiple formats. So let's look at what we can do in such a case. Okay. So like I said, the parseDateTime function is going to be used to handle such a scenario. And it has this orders argument that will allow us to specify the multiple date formats that we want to check for. So we're going to start now with a basic example. So let's start with a basic example for using parseDateTime. I'm going to parse the following date, 30/07/2001, which is July 30th, 2001. And I'm going to give this orders argument, which is going to be equal to DMY, where D is for day, M is for month, Y is for year, of course. If I run that, we'll see that this accurately parses as 2001, July 30th. And it appends the time zone UTC. You don't really need to think about time zones for now. So this worked like we would expect it. But of course, that's not the real use of parseDateTime, because this would just be equivalent to using DMY, which is going to work for a single format. The reason we're using parseDateTime is for when we have multiple formats. So let's go ahead and take a look at that. So like I say here, the power of parseDateTime is truly evident when you're handling multiple formats. Let's look at a quick example there. So parseDateTime, we're going to give it the following two arguments. The first is going to be a vector of our two dates. The dates we want here are going to be 1st of January 2000, okay? And then in a different format, we're going to have July 30th, 2001. And what are the orders going to be? If you want, you can pause the video to try to figure out the orders. But it's just going to be like this. Orders equals, again, a vector. And then this is DMY. So orders equals C, DMY, comma. And the other one is, of course, MDY. And if we run this, we'll see that both of those are parsed accurately, 2001 and 2001-0730. Now, the order in which you supply the formats to this orders argument here doesn't matter when the date strings are distinct, when there's no ambiguity. That means that if I take this one here and I have first MDY and then DMY, it'll still parse correctly and everything will be the same as before. So MDY and then DMY. And as we can see, it's still the same output. But there is a situation when how you arrange those different formats in the orders argument will matter. And that's in cases of ambiguity. So let's take a look. Like I write here, ambiguity in dates can be a challenge. For ambiguous dates, the order in orders does matter. So if you take a look at this example here, parseDateTime 0102-2000 and 0103-2000, both of these dates could either be month, day, year, or day, month, year, right? Hopefully that makes sense to you, which means the order in which we provide this vector of options will matter. If we provide it with the MDY first, like it's done here, then these are all going to be interpreted as months. So this is now interpreted as January 2nd, okay, January 2nd, and this is interpreted as January 3rd. However, if we then put the DMY option first before the MDY option, now these will all be interpreted as the day, and this will be the month. So let's go ahead and try that. If I run this, you can see that these dates are interpreted differently This one prioritizes DMY and this one prioritizes MDY. What does this mean for your data analysis? It means that if you have a column where the values are entered like this, and some people enter it as DMY and others enter it as MDY, there's really nothing you can do to sort out that ambiguity. So you have to be careful at the point of data entry. Now here's some practice for you. So I want you to use the parse datetime function from lubridate to parse the following dates. So the dates should be here: November 9th, 2002, December 4th, 2001, and June 5th, 2003. So indicate in the orders argument here the symbols needed for parse datetime to understand those dates as given. So now let's return to our dataset and see if we can clean up this start date messy column using parsed date time. Okay, so I've looked through that column and I noticed that there are 4 different formats. This is something you're going to have to do. There's this one, the YYYY/MM/DD. There's this one here with month first and the month written out in words. You have this, and finally you have this. So you're going to have to go through your data and check what the different formats are, and that will inform what we give to the orders argument. So now we're going to use parse datetime to clean up that variable. Let's quickly take another look at the variable here. Okay, so we can see some of those formats we talked about. So we're going to say mutate start date messy equals parse datetime start date messy, and we provide all those orders. So orders equals, we open our vector here, and the 3 different formats we have are month, day, year, comma, date, month, year, and finally year, month, day. Okay, let's quickly check that. This one, for example, is month, day, year. This one I'm not yet sure what it is, but if you scroll down, we'll see later what that one is. So that we have month, day, year. We have this one is definitely day, month, year. Okay, and how about YMD? That's definitely this one is YMD. So we have those 3 formats, and we can run that. And we can see that it seems to be parsed all correctly. If we want to check, we can mutate it as start date messy 2 or start date messy clean, or maybe just start date clean, and we can check to see that all of those were interpreted correctly. Now you may wonder whether the order in which these guys here, MDY, DMY, and YMD, the order in which we arrange them matters in this case. Let me put an enter here so it's easier. And we can test that to see whether it matters. So let's go ahead and try a different order. So again, we start with the start date messy column. And what I'm going to do now is I will parse date time. And for the first option, start date messy 1, we start with MDY and then DMY. For start date messy 2, we start with DMY and then MDY. So let's run those and see if those 2 are equivalent. Okay, so we can see that from these first 10 rows, they seem to be all equivalent. I have actually gone through to check that they all are. This is something you can do on your own time. And you may wonder, how come they are equivalent? Well, I'll tell you. Okay, like I said, if you scroll through, you'll observe that these conversions are all the same. Now, the reason all these conversions are the same is because there's actually no ambiguity in this data set. Okay, and we know that the order in which you provide these arguments or these elements to the orders function only matters when we have ambiguous dates. Let's dig in a bit deeper. You may think there is ambiguity in this variable, because notice that this first one here, we can just take that slice. This first value here, 040714, could in theory be April 7th, 2014, or it could be July 4th of 2014. However, what you will notice though is that it was read in, okay, as April 7th in both cases. Even when you specified, let's go up here, even when we specified DMY as the first thing, the first priority format, it still insisted that this is a month, not a day, even when we specified DMY as the priority format. Okay, still insisted that this thing is a month, and it put it here in the second position for April. Okay. Why is that happening? Hopefully you have some kind of clue. If you don't, then scroll through the data set and tell me if you still don't have a clue. Okay, now I'll tell you the reason. Okay, this is because there are other rows that resolve the ambiguity. Okay, for example, let's take a look at row 11. If we keep scrolling here, if we go to page 2, Row 11 here is 062614. Now this one is definitely not ambiguous. This must be the month and this must be the day. And we can highlight that by just slicing 1 and 11. So although this format here seems ambiguous, lubridate can infer that these two must have been entered in the same format, and since this one isn't ambiguous, this one must be June 26th, then similarly this must then be April 7th. Hopefully that makes some sense. In words, what I just said again is that this row can only be interpreted as June 26th, okay? And that number 26 cannot represent a month. And so therefore, finally, lubridate knows that all rows of this format, XX/XX/XX, are indeed MMDDYY. That was a bit of a long explanation. Hopefully you found it useful to understand how lubridate works. Here's another practice question for you. I want you to use parse date time to clean up the admission date messy column in that inpatient dataset that we imported at the start of the lesson. Now, the final thing we're going to look at is how can you change the way dates are displayed. So far, we've been thinking about how you can import dates of different formats. What about when you want to export or print dates in varied formats? That's what we're going to look at now, changing how dates are displayed. So up till now, I've said we've been using the date class with the default YYYYMMDD format. Let's see how we can display dates in a specific format, for example, for your reports or for graphs or tables. Okay, we're going to use the format function in base R for this, and it's fairly simple to use. It gives us the freedom to customize the appearance of our dates as we please. And it's going to use the same set of symbols that we introduced earlier for using the as.date function. So now you actually do have to learn these symbols. We'll go through a few of them again. Remember that the Y stands for year, and if it's capital, it's 4 digits. If it's small, it's 2 digits. Remember that M stands for month, and those are in digits. B is month, but in letters. Capital B is the full version, and small b is the abbreviated, and D is for the day of the month. And those are the most important ones. You can look at these ones later. So let's see how we can use these within the format function. So we'll try a simple example where we want to convert this date, 2001-31, and print it like this in our console. Or if we wanted to do that in a report or a graph, we could do the same. Okay. So let's first define this as a date in R. 2001-31. I'll copy that. Okay. And now we want to print it out in this format. Notice that if we just print my.date or my_date, it prints in this default format. But we want to print it like this. So we want first the month as a set of letters, okay, as a word, and that is going to be this month abbreviated. So we put it that way. We do $B, okay. Then we need a space, and then the digits for the day, which is $D here, so $D, and then there's a comma, and finally, and then a space, and then finally the 4-digit year, which is $Y, okay. $Y, and we can run that, and we see our final output indeed resembles what we wanted. Now here's some practice for you. I want you to format this date below to the following format, mm/dd/yyyy, okay, using the format function that we just taught you about. Now let's try to apply the format function on our actual data set. To do this, we're going to create a new variable called startDateChar from startDateDefault, okay, and we'll try to display it using the following format. So let's go ahead and do that. Let's first select start date default to see what it looks like. Select start date default. Okay. If we run that, we can see what that looks like here. Okay. So it is already in the standard rdate format, but we want to print it in this non-standard format here. So we say mutate start date char equals, okay, format function. Again, this is from base R. We start with start date default. And we say that the format that we want is dollar sign, or not dollar sign, percent sign D for that 2-digit day there, okay, small d, and then a slash, and a percent sign M for the month, slash, percent sign capital Y for the year. Okay, and I'll select both the start date default and the start date char so we can compare the outputs. We can see that it does seem to be correct. This one was 2014, April 7th, and this is also, if you think of it in DDMMYY format, the 7th of April 2014. Okay, we can just try one more format. Instead of the percent sign M, let's try percent sign B. And instead of the slashes, let's have spaces. Okay, so if we run this now, you can see again that this works out really nicely. Now let's try one last example. We're going to use end date default and try to format it using this following format. Okay, so let's start by selecting end date default, end date default. Okay, and we're going to try to format it as a month DD and then 4-digit year. So end date char equals format of end date default, comma, and what is our format? It's going to be percent sign, pause and think about it. This is the full month, so percent sign capital B, then a space, then the day, percent sign, percent sign D, a comma, and then percent sign capital Y. And we can select both the end date default and the end date char, that's our new variable, to compare them, and it looks to be indeed correct. And that actually brings us to the end of our lesson. Let's take a quick look at the learning objectives and see if you've understood all of these. Our first hope is that you can understand how dates are stored and manipulated in R. Hopefully you now understand that. Secondly, you should understand how to coerce strings to dates using the as.date function and as well the lubridate functions. Thirdly, you should know how to handle different messy dates using the parseDateTime function. And lastly, you should know how to change how dates are displayed using the format function. And through all of those, you should also remember the symbols required for different date components. So congratulations on finishing this first dates lesson. Now that you know how to parse dates in R and how to format them for your specific needs, you can now look at how to manipulate the dates and how to create basic time series graphs. These are topics we will consider in the next dates lesson. I will see you there. Bye-bye.